All right, so 4-1 is just an introduction to congruent triangles or congruent figures, really, because it doesn't always have to be triangles. Most of what we're going to do is going to be triangles, but any figure will work. You can see figures on the board. This is one of the questions on your homework today, actually. So let's just start with congruent polygons. A polygon is just a figure that has closed edges, not a circle. Congruent polygons, so two figures that are congruent to each other, will always have congruent corresponding parts. Okay, so if you look at those two figures, there's a yellow and a blue triangle there. They have congruent corresponding parts. So the way the book or the way your quizzes, things are going to go, you'll have something like this. It'll say triangle ABC is congruent. Can anyone tell me which triangle it's congruent to over here? If I say ABC, then I have to say what? DEF. You have to match up the corresponding parts, okay? So triangle ABC is congruent to triangle DEF. What does it mean to be congruent? The same, equal, right? So the thing is, with congruent triangles, their corresponding parts have to be congruent. So that means all of their sides will be congruent to the corresponding side, and all of their angles will be congruent to the corresponding angle. So for instance, if you look at this picture, we would say angle A is congruent to what? Angle D. What if we didn't have the pictures? Could you tell me the rest of the angles that are congruent? Could you tell me without looking at the pictures right now what angle B should be congruent to? E, right. So we said A was congruent to D, the first letter of the one triangle with the first letter of the other triangle. Then we said B congruent to E, right? The second letter with the second letter. So again, without even having to look at the triangles, you can say the third letter will correspond to the third letter. So it matters how you name them. You have to name them with their parts matching up, okay? Okay, so ignore the pictures for a minute. Don't even look at them. Don't scribble yours out. You can keep yours. But if you're looking at my screen right now, and I ask you to tell me which segments are congruent, what do you tell me? Let's start with AB. Segment AB should be congruent to what? DE. The first two with the first two. Okay? If they're telling you those triangles are congruent, they're telling you in a corresponding order. So AB is congruent to DE. So what is BC congruent to? EF. Okay? What is AC congruent to? DF. Want to know a secret? You just did the first question of your quiz. I'm going to give you two triangles, and I'm going to say, tell me the congruent corresponding parts. And you're going to tell me these three angles are congruent to these three angles, and these three segments are congruent to these three segments. Okay? Match up the corresponding parts. If you can do that, it makes this whole chapter a whole lot easier. Okay? Match up the corresponding parts. Okay, so take a look at this. It says if triangle ABC is congruent to triangle YXZ, what are the congruent corresponding parts? Now here's why I say look at the letters more than you look at the picture, because these triangles look very similar if you just rotated the green one on top of the blue one, or if you flipped the green one onto the blue one. Which of those two things is actually happening here based on my lettering? Does it just rotate to a new position, or does it flip over to its new position? It's going to flip. If I say A corresponds to Y, here's A, here's Y. In order to get that into that position, I would have to flip it over onto that spot, right? So yes, you may use pictures. I think it's best if you use the names they tell you, okay? So if we're going to name the congruent corresponding parts here, we would say angle A is congruent to what? Angle Y, Okay, angle A is congruent to angle Y. Angle B is congruent to what? Angle X, the middle letter with the middle letter. Okay, angle B is congruent to angle X. And then the third one, angle C, is congruent to angle Z. Okay, so we're matching up the congruent corresponding parts. And you would do the same thing with the segments again. I'm not even going to make you do that because you already did it up here. But I just want you to see well, I will do it real fast. You don't have to write this down necessarily. I would say AB corresponds to what? YX. AB is congruent to YX. I would say BC is congruent to XZ. And then the first and the last, AC, is congruent to YZ. Okay? So these match up, and these match up. Okay, knowing that, look at part B. It says if the measure of angle A is 72 and the measure of angle Z is 78, what are C and B? What are those angle measures? I think it is super helpful when they tell you angle measures if you put them on the picture itself, because it kind of helps you to see what corresponds and what we know about them. So if A is 72, I'm going to put a 72 right there. And if Z is 78, I'm going to put a 78 right there. Okay? We want to know the measure of angle C, knowing that these two triangles are congruent. Can anyone tell me what the measure of angle C should be? It's 78, right? We said C corresponds to Z. So if Z is 78, then C is also 78. Okay, so you are just matching up those corresponding parts that are congruent. And I would write it in again because it's going to help you find the next thing. How do you find angle B? Yeah, this is going to equal 180 degrees. It's a triangle, right? So 72 and 78 and whatever this angle B is should add up to 180. So you're going to go 72 plus 78 plus the measure of angle B equals 180. Okay, and now it's just a matter of take this away. So this is 150, so take away 150, and the measure of angle B is 30 degrees. Can you tell me the measure of angle X? 30. Yeah, it's the same as B, so this would be 30. Can you tell me angle Y? 72. It's the same as A. Okay, so if those triangles are congruent, everything about them is congruent. Isn't that lovely? So good, right? Okay, there is a theorem called the third angles theorem, and here's what it says. If two angles of one triangle are congruent, equal, the same, right, as two angles of another triangle, then the third angles are also congruent. I'm going to draw you a picture to show you what I mean. If you have a triangle here, we'll call it ABC. And then you have a triangle here, we'll call it DEF. Okay, here's what the third angles theorem says. If angle A is congruent to angle D, and angle B is congruent to angle E, then what is true of C and F? They're the same. Why are they the same? Does anyone see it? Why do we know, just given these two angles, that C and F will also be the same? What factor comes into play here? Grant.
That the first two are congruent.
Right. Why does that help us? What do you know about a triangle? What? Hey, what? They equal 180. Okay, so think about this. If 3 things have to add up to 180 and 3 things have to add up to 180, right? Then the 2 that are the same, take those away. What are you left with? The same thing on both sides, right? So if the 2 equal each other, then the third one has to be congruent as well, okay? So the third angles theorem would say, here, I'm going to change the color on this. The third angles theorem would say angle C is going to be congruent to angle F. Okay? Any questions on that? Okay. Let's do a proof. Tell me what you know about proofs. Tell me anything you know about doing a proof. The first step is always your given information. All right, so let's write that down. This information goes right here, and you don't have to rewrite it for me. You can take a circle around it and draw an arrow to that first line every single time for me. That is fine. What goes right here? Given. Okay, so your first step is always given. That's one thing we know about a proof. What else do you know about a proof? Anything. Not this proof, any proof. It ends with what? Whatever they asked you to prove. Yes. So this, whatever they're asking you to prove, is always your last step. Not the reason for it, but just the step, okay? So it's always going to be triangle LMN is congruent to triangle LON, okay? Your job is to figure out, how do we get there? The other thing to know about a proof is there's always a picture with it. So this, right, that picture is helpful in lots of ways, and you just have to figure out what ways are those, okay? So we just said, in order for 2 triangles to be congruent, what has to be true about them? If 2 triangles are congruent, then all of their corresponding parts, angles, sides, okay, have to be congruent. So if I can prove that all my sides are congruent and all my angles are congruent, then I've proved the triangle's congruent. Today's the only day you're going to have to do that. I give you shortcuts from here on out, okay? But for today, we got to prove 6 things. We got to prove 3 pairs of sides and 3 pairs of angles are congruent. Now, the beautiful thing about this proof is they did most of the work for us. So the first thing it says is that in the given, LM is congruent to LO. If it's marked for you in the picture, it is given, okay? So if it's marked, you can say that's given information. The second thing they say is MN is congruent to ON, so that's given. So they gave us 2 of the 3 sides are congruent. Do you see where the third side is for both triangles? What's the third side on the top triangle that we don't know is congruent to the third side of the other one? It's the same line. It's LN, right? LN on the top triangle is the same LN on the bottom triangle. Do you remember when I told you, who did I use in here? Who looked in a mirror and saw themselves in this room? Who? Devin? Devin looks in the mirror. She sees Devin. Which property was that? Reflexive. This is where you're going to use the reflexive property all the time, okay? So this is the reflexive property. If LN looks in the mirror, it sees LN, right? That's the reflexive property. The reason we have to say it is LN is a side of one triangle, but it's also a side of the other triangle. This is where the reflexive property comes into play, okay? So LN congruent to LN. I would mark it just so you know you've done it. So now we have all 3 sides congruent to all 3 sides. We're halfway there. We have to say all 3 angles are congruent to all 3 angles. They did 2 of them for us already. Let's take a look. In the given, it says angle M is congruent to angle O. It also says angle MLN is congruent to OLN. What's the vertex of those angles? What point is the vertex? It's always the middle one, okay? Why did they use 3 letters instead of 1? They used 1 letter up here, M and O. Why did they use 3 on that one? Why can't I say angle L is congruent to angle L? Why can't I say angle L is congruent to angle L? How many angles do you see at vertex L? Two. Technically, you could say there's actually 3, right? You could say this angle, you could say this angle, or you can say that angle, okay? So there's 3 angles there, which is why you can't just say angle L is congruent to angle L, because which L are you talking about? I don't know. The reason you can say angle M up here is there's only 1 angle there. The reason you can say angle O down here is there's only 1 angle there, okay? If there's multiple angles coming off a vertex, you have to use 3 letters, and your middle letter has to be the vertex. So they say MLN is congruent to OLN, and that is given. So the only thing we're missing is why is this angle congruent to that angle, right? We have to say it. We have to say angle MNL is congruent to angle ONL. But why do we know that? I just taught it to you a few minutes ago. Look in your notes. How do I know that this angle is going to be congruent to that one? What? They are corresponding parts, but how do we know they're congruent? Grant?
The third angles theorem.
It's the third angles theorem. If we know the 2 angles are congruent, then the third ones have to be congruent as well. So this is the third angles theorem. Okay. Okay, so we just got 3 sets of angles that are congruent and 3 sets of sides that are congruent. So we can say the triangles are congruent because all corresponding sides and angles are congruent. Okay, this reason, today's the only day you have to use it, because from here on out, instead of having to give 6 things, all 6 corresponding sides and angles are congruent, you'll just have to give 3. So today is the only day of the entire chapter that you'll be telling me that for the reason. You will be doing, you don't have to write these down. This is going to be your notes moving forward. But you're going to do 5 different reasons why triangles can be congruent. Any guesses what an S stands for right now? If we're talking about triangles? Sides. Those are the sides of the triangle, right? We're matching up congruent sides. What do you think the A's stand for? Angles, congruent angles in a triangle. Any guesses what an H and an L might stand for? Height is a good guess. It's not height. I'm going to give you a hint. Any guesses in that triangle what an H might stand for? There it is, hypotenuse. H is hypotenuse, okay? It's the side across from the right angle. Any guess what the 2 other sides are called in a right triangle? What would an L be?
Long side.
It's not a bad guess. It's not the long side. What? Not longitude, but that's a good guess too. Or lateral, good guess. No. You have a hypotenuse and then you have 2 legs. That's where the L is going to come into play. We don't do that until we get to 4, 6, I think, but just, giving you the stuff ahead of time. The one thing that I want to show you, because this is part of your homework question, and you will also see it somewhere else in a few days, is this. Let's say I have these 2 triangles, and I tell you these lines are parallel. I want to know between red and green. Can you tell those are red and green up there? Which ones are congruent right now? The red ones, the green ones, all of them? It's not all of them. Which two? Based on what you see in this picture, is it the red ones that are congruent or the green ones that are congruent? The red ones. Why?
She guessed.
Because it was 50-50 and I guessed the right one. It's the red ones, but there's a reason, and you know the reason. Yes. Because you have alternate interior. Okay, so here's the deal. Because some of you on the quiz, when you get to something like this, because it's there, are going to tell me alternate interior for both of these sets of angles. These are alternate interiors because these lines are parallel, right? These are parallel, and this is our transversal. We did not get told that these are parallel. Therefore, you cannot say that the green are congruent by alternate interior angles, okay? It's the red ones that are congruent by AIA. What if I told you this? Now can you tell me that the green are congruent? Why? We don't know they're parallel. Why? No, I taught it to you today. The third angles theorem, right? If you know 2 and you know 2, then the third will be congruent as well, okay? So there is this third angles theorem. It's helpful when you know 2 angles of one triangle are congruent to 2 angles of another. Don't turn everything into alternate interiors. I didn't tell you these lines were parallel. They're not alternate interiors if I don't tell you they're parallel, okay? I mean, they are, but they're not congruent alternate interiors. Okay.